Hello everyone. This is Abhijit Dasgupta from 3665 Tech, and welcome to another session of FLO Blockchain App Development by SkyPiCast. We would like to thank Ranchi Mall for their continued support in our blockchain journey. In this session of today, we will continue our discussions on the concepts of blockchain that we started in the previous session. Just to remind you all again, we will be having these live online sessions till 15th of September 2018, every Tuesday, Thursday, and Saturdays at 9 p.m. IST. So don't forget to tune into all of those to continue this journey of apps development on FLO Blockchain with us. Just as a heads up, this is a page in our presentation wherein we have listed down a few links of URLs and resources which we have also used in these sessions, and you can also access these to get details and those resources too. So we have used these links for different slides that you will be seeing in the upcoming presentation. And you can also we will also add these in the description of the video in YouTube when we do. So let's move ahead. So let's do a quick recap of what we discussed in our previous session. In our previous session, we discussed what a blockchain is, what a blockchain technology is, different types of transactions or how to do transactions in blockchain. What is the life cycle of a transactions in blockchain? What do we mean by blocks? What are hashes? We discussed about cryptography, public-private key cryptography, asymmetric key cryptography, symmetric key cryptography, and the different types of keys. And also we discussed in the last session, what are the different types of blockchain, like public blockchain, private blockchain, and permission blockchains. So, and consortium blockchain, of course. So these were some of the topics that we discussed in the previous session. We would like to encourage you to reach out to us after our sessions with your suggestions, feedback, any questions that you may have with our sessions. And please do reach out to us in the email ID abhijit@3665tech.com, which I have also mentioned in the last slide of this presentation. And we generally tend to revert back in a day or two's time with your questions. So we will be very happy if we could hear from you. So let's move ahead into today's discussion. So in today's discussion, we would be talking about the concepts of cryptocurrency, what consensus algorithms are, and what problems they solve and how they solve those. We will also be discussing some consensus algorithms like proof of stake and proof of work. We shall also be discussing mining, the concept of mining, and what miners are and what miners do. We will also be having a look at different types of miners and mining pools, the concepts of mining pools and miners. Lastly, we will be discussing about crypto wallets, their use, and different types and classifications of these wallets. In today's session, we will also have some hands-on time in setting up a CPU miner and mining some flow transactions, both using a mining pool as well as individually. Of course, we will be doing the individual mining on the testnet. As we discussed, there are two networks in blockchain. One is the testnet for doing all test-related transactions, and one is the mainnet, which contains all live transactions. So we should be doing some mining work also. So let's move ahead with the session. So starting with our first topic of the day, cryptocurrency. I'm sure most of you, if not all, must have heard about Bitcoin or some other cryptocurrency. But even if you have not, let's see what they are. A cryptocurrency is basically a digital or virtual currency designed to work as a medium of exchange, which uses cryptography to secure and verify transactions, as well as to control the creation of new units of a particular cryptocurrency. In the last session, we discussed about the concept of blockchains. Cryptocurrency, if you may, is something which is built on top of a blockchain technology. It is a form of a digital or virtual currency which is designed to work to exchange some sort of transactional value. Any blockchain, be it Bitcoin, Bitcoin Cash, Florine Coin, Flow, Ethereum, they all have the underlying blockchain technology working for them. And the overlay, the transactional tokens that are used, they are called the cryptocurrency. Obviously, cryptocurrencies use cryptography to secure and verify these transactions, as we discussed in our last session. Every transaction that gets created in a cryptocurrency is collected in and encapsulated in a block, and then those blocks, when mined and validated, form part of the existing blockchain. Cryptocurrencies use decentralized control as opposed to centralized electronic money and central banking systems. In any form of financial or banking transaction systems that we see in our day-to-day life, they generally have a centralized electronic system to manage all the transactions. Cryptocurrency, on the other hand, uses decentralized control. The decentralized control of the cryptocurrencies works through a distributed ledger technology, typically a blockchain, and it serves as a public financial transactional database. Like we discussed in our previous session, this blockchain, on top of which a cryptocurrency is running, it generally is a public financial transactional database, like in form of Bitcoin or Flow. But there could be some other currencies also, which are used by enterprises for their own internal usage, for their own internal consumption, and they may not be public also. One of the first cryptocurrencies, or if not the first cryptocurrency that was released, was as an open source software in 2009, and it is known as Bitcoin. I'm pretty sure all of you must have heard about it and its boom in the previous year. It is generally considered the first decentralized cryptocurrency, and since the development of Bitcoin, more than 1,000 of altcoins or alternative coins or variants of Bitcoin have been created using the same protocols and the same technology that Bitcoin used. Bitcoin is created or developed by a pseudo-anonymous person or a group of persons named as Satoshi. It is not very much known whether he is a pseudo avatar or a real person, but let's not get into that. Just to continue our discussion on cryptocurrency, to realize any digital cash, we need a payment network with accounts, balances, and transactions. One major problem with every payment network is to solve the so-called double spending, which means to prevent one entity from spending the same amount twice. Usually, this is done by a central server which keeps records about the balances of accounts. Let's imagine for a second if we have 100 rupees available with us, and if there is a possibility that we could spend that 100 rupees in two places and buy goods worth 100 rupees from two places. Wouldn't it be nice? But obviously it is not possible in our real world examples. Once we spend something, that money or that particular currency gets spent, and we cannot double spend that amount. This is very much possible in a real transactional system where a central server keeps all the balances. But in a decentralized network, we don't have this server to maintain all these balances. So what we need is for every single entity of the network to do this exact same job. Since blockchain is a peer-to-peer network, every peer in this network needs to have a list of all the transactions to check whenever future transactions are happening, whether they are valid or they are an attempt to double spend. So the technology behind blockchain actually and the cryptocurrency actually checks and prevents the problem of double spending. This is done through a technique called consensus. If the peers or the nodes of the network disagree about only one single minor balance, everything gets broken. We need an absolute consensus on all the transactions that are happening on the blockchain to maintain this. Usually, we take again a central authority to declare the correct state of balances. But when we talk about a decentralized blockchain-based cryptocurrency, this consensus is achieved without a central authority. And how is it done? It is done through consensus algorithms. So let's move ahead and see what these are. So consensus algorithms are basically algorithms which are at the core of what make cryptocurrencies decentralized. They are tools that facilitate the agreement between millions of users worldwide on what the playing rules are going to be, as well as the punishment and rewards for disobeying or obeying them. Basically, these consensus algorithms are what make the entire blockchain or the cryptocurrency network go. They actually maintain which transactions are to be allowed, which transactions are to be discarded based on these consensus. Every consensus algorithm that are used in blockchain-based cryptocurrencies must possess what is called a Byzantine fault tolerance or a BFT. When we say a system possesses Byzantine fault tolerance, it means that the system can function properly even in the event of a failure caused by what is called a Byzantine generals problem. You might ask, what is a Byzantine generals problem? Just like many other concepts in computational computer sciences, Byzantine generals problem has also been defined using a sort of a situation. If we just see what the situation is and how this Byzantine general problem can be explained. Say we have a group of generals in a war, each commanding a division of a Byzantine army, which need to decide whether or not they are going to attack an enemy city or not. The generals communicate with each other only through messengers, and they are located at different positions and cannot directly talk to each other. The only way they can communicate is through the messengers that they have. Whatever the decision may be, it is important that it is agreed upon by every general, because an uncoordinated attack would be worse than having either a coordinated attack or a coordinated retreat. So the problem is further complicated by some traitorous generals or some intentional generals who are in between them, who try to prevent the loyal generals from reaching the agreement, as well as unreliable messengers who may intentionally or unintentionally act in an unhelpful manner. Therefore, a solution is needed that ensures that all generals decide upon the same plan of action. A small number of traitors cannot cause the loyal generals to adapt an unreasonable plan of action. Even though, at first glance, this problem of Byzantine generals problem may seem deceptively simple, but a simple algebraic calculation shows that it requires at least 3n plus 1 loyal generals to cope with n number of traitors. So if we put it in other words, this problem can be solved if more than 2/3 of the generals are loyal. A single traitor can still sabotage the attempts of 2 loyal generals. So, as per this Byzantine generals problem, any blockchain must have at least more than 2/3 consensus to have Byzantine fault tolerance. And hence, we can have the consensus based on this Byzantine fault tolerance, and the entire blockchain and the transactions maintain their sanity. In other words, it's a consensus problem, and any consensus algorithm must be following this Byzantine fault tolerance algorithms to actually maintain this entire blockchain sanity. There are 2 types of consensus algorithms that are generally in use in current blockchain technology. Both of those are proof of stake or POS and proof of work or POW. Let's have a look at the difference between these two. If you look at this infographic for a moment, we can just have a quick glance at the different differentiations that exist between proof of work and proof of stake. Let's just go ahead and see one at a time. In proof of work, the probability of mining a block is determined by how much computational work is done by the miner. Let's just note one thing. In proof of work, the validators or the people or the systems or the nodes who are performing these sanity checks and validations of transactions are known as miners. And the probability of mining a block is determined by how much effort they are putting in. And this effort, in turn, is the actual computational work that is being done by them. On the other hand, in proof of stake, these miners which are available in proof of work are generally known as validators. In proof of stake, the probability of validating a new block is determined by how large of a stake a person holds, which in turn translates to how many coins they possess. So, if we just try to explain these one more time. In proof of work, the amount of work that a miner puts in, the more amount of work that he puts in, the probability of mining is a block is more for that particular miner. But in proof of stake, anyone who has a higher stake in terms of the number of coins that they possess or the age of coins that they have more say in validation of the transactions. Coming to the second point, in proof of work, a reward is given to the first miner who solves the cryptographic puzzle of each block. So no matter how many number of miners are working to mine a particular block, and they might have worked is the first to solve the puzzle is actually rewarded and others are rewarded nothing. In proof of stake, the validators do not receive any block reward. Instead, they collect only the network fee as the reward. Whichever transactions happen, every transaction has a transaction fee, and these fees are only collected by the validators as part of their rewards per se. But in proof of work, the miners do get the transaction fees as well as the reward. But we will talk about this reward part a little bit later also. In proof of work, network miners compete with one another using computational power. Mining communities tend to become more centralized over time. What we will see in our later slides also, that currently it is getting a bit unviable to mine individually, because the computational power that is required to mine the blocks and succeed is making the entire process of mining individually pretty much unviable. To tackle this, what people have done is miners have come together and formed what they call as mining pools, wherein miners share and contribute their mining power into a single pool, and the entire pool with the accumulated computational power of all the miners can perform the computational task a lot faster and financially viably. So this is something that we will also be talking about in our later slides. In proof of stake, systems can be much more cost and energy efficient than proof of work systems. But these concepts of proof of stake are still not proven like proof of work. So in proof of stake, though they are cost effective, energy efficient, they have some concepts which still need to be proven to be completely used, just like proof of work is used in most of the blockchains that we currently see. Let's go back to what discuss about proof of work a little bit more. Proof of work, as the name states, is the validation of the work that happened and proving that it is correct. Bitcoin and many of its alternative coins follow this exact way of consensus to make sure the authenticity of the blockchain is good. To understand how it works in simple terms, assume that you are appearing in a maths examination along with other students in your classroom. The student who can not only come up with the correct answer, but also comes up with the complete proof and the steps of arriving at the correct answer first gets the reward. As we know, this needs the student with a lot of brain power, which naturally consumes a lot of energy from the body to have this to happen. In terms of blockchain, if we map this same analogy, the maths exam that we discussed about can be referred to a transaction. The classroom can be referred to as the entire world. The student can be referred to as the computing hardware or the computer that runs those complex mining algorithms. And brain power can be referred to as the computing power that is used in solving those mathematical complex algorithms. And the energy that we talked about can be referred to as the electrical power that is consumed during all this mining process. Now, keeping this above analogy and experience in mind, we can summarize proof of work as something which is a concept or approach which has its own benefits but also has its downsides. If we look at its downsides, it requires a lot more power, which in turn costs the miner. So, for a miner to have a viable return of mining a particular coin, he must have enough earning from mining the coin, which can actually compensate and give him profits after paying for all the electrical power and different resources that he has used. A high computing power hardware is also required, which is very expensive. Possibility is there that miners may move their hardware that is available to them for mining purposes only to a different coin altogether if the reward is better there. Say, in today's terms, mining Bitcoin using a CPU miner or a GPU miner or even an ASIC miner is very much unviable. That is just because of the difficulty that is currently prevailing in blockchain of Bitcoin. And people who might individually mine may take years to actually mine even a single Bitcoin. And the cost to mine that would be huge and may not even cover the cost that the Bitcoin that they mine provides. With more and more coins getting released, the miners' rewards would also come down as the coin becomes scarce to mine. This is something that we will be talking about a little later in terms of the number of coins as reward getting lower and lower as the days progresses. This is something of a topic which we'll be discussing in later our slides. The next consensus algorithm that we saw in our previous differential infographic site was proof of stake. Let's just have a look at this. Proof of stake or POS is an alternate way of verifying and validating the transactions or blocks. It is mostly used in one of a very popular blockchains which is called Ethereum, the cryptocurrency Ethereum. It uses proof of stake. What it does is it will pick the validator, which is equivalent of a miner in proof of work, by the amount of coins or the stake the validator has and the respective age of the stake. Say, for example, if you have 100,000 coins, let's say X coin, which uses proof of stake in your wallet, and it will have an age attached to it on how long you have been acquiring it or how long you have it with you. So here, the 100,000 X coins is your stake in the blockchain. If you move your coins from one address or wallet to another, the age gets reset and obviously your stake lessens. This amount is like a security deposit, which means that the validator holds a significant stake in X coin with good aging, and he is more committed and combined with many other factors. and he will be getting a higher chance to validate a block in comparison to someone who has lesser number of coins and has been holding them for a lesser amount of time. This allows in building a trusted and distributed network with loyal validators who have high stakes of coins. The validators earn the part or whole of the transaction fee. In this POS or proof of stake, it is not known as mining but forging, which is done by the validators who will process and forge a block to the chain. When we use proof of work consensus algorithms, we say that a block is mined and attached to a blockchain. But in case of POS or proof of stake, we call that block is forged and then attached to a blockchain. This particular scenario that we discussed in proof of stake, this actually eliminates the challenges that we saw in proof of work, and it has the following advantages per se over proof of work. There is no need of expensive hardwares to run a proof of stake blockchain. The energy efficiency is high because it won't consume high electricity and high power equipments to mine or validate proof of stake blockchains. The validators are more loyal because they have higher stakes. As higher the stakes of value, validators have have a higher stake for a longer time. More chances for the validators is there to be picked up for forging and earning the transaction fee. Also, the validation process is faster. If we just have a look at these 4 points that we just discussed, it seems that POS has a lot going over POW. But the actual scenario is that the entire proof of stake algorithm is still not proven, and there are currently issues with it, such as a small group of people owning a majority of the tokens and coins will be the validators and can manipulate the entire process. But this entire process is still evolving, and eventually more solid and robust systems will be out there at some point of time, which will probably make this proof of stake consensus algorithm more acceptable, which will bring down the expensive hardware costs, energy efficiency, which is the major criticism point of proof of work. So this is something that may happen in future, but currently POW is still the way to go. The next section that we are going to discuss in this session is about mining and miners. We will first be looking at what the entire process of mining is, what miners are, what are the type of miners that are available. The mining is a basic process which means to validate new transactions and record them on the global ledger or the blockchain. Miners basically compete to solve a mathematical problem based on a cryptographic hash, which we discussed in our previous slides as well. The solution that they find is called proof of work. Just to recap a bit or take your focus to this particular topic of mining, we are only going to talk about mining in our future slides, just because we are going to be using FLO blockchain, which actually uses proof of work and uses mining rather than forging or proof of stake. So we will be confining our discussions to mining based on the proof of stake algorithm or the consensus algorithm that is being used for our FLO blockchain. That is why we are only going to concern our focus on mining. Just to continue, the solution that is found during mining is called the proof of work. That is, the work that has been done needs to be proved. This proof proves that a miner did spend a lot of time and resource to solve the problem. When a block is solved, the transactions contained inside that block are considered as confirmed and complete, and the crypto coin concerned in the transactions can now be spent. So when you receive some coin on your wallet, it will take approximately a few minutes, about 10 minutes, for your transactions to be confirmed, as it is in case of Bitcoin and similar altcoins. Miners will receive a reward when they solve the complex mathematical problems. The reward that a miner gets is in two forms. First, either in form of new coins or in form of transaction fees. The amount of coins that get created in a blockchain during every mining process gets decreased after every n number of blocks as is defined in the protocol for that particular coin. This number will keep on going down until there are no more new coins to be issued. This is something, this number of blocks getting decreased is called reward halving. So reward halving is a concept wherein after a set number of blocks, the number of crypto coins that are provided as reward to the miners get halved. This is something that is happening in Bitcoins. This is something that is happening in FLO. It happens in every proof of work coin. So I say n number of blocks because this is something, the value n is different for different coins. Miners can also receive rewards in form of transaction fees. Just in the last session that we discussed about transactions, we said that whenever we do a transaction, we actually transfer a certain value of the cryptocurrency from one address to another. I also mentioned there that for performing any transactions, you need to pay a transaction fee to the network. In a decentralized network or a decentralized technology like blockchain, the transaction fee must be acquired by someone. The transaction fee that I paid for doing a transaction, it must be transferred to someone. So who does it get transferred to? It gets transferred to the miner who actually mines my transactions. So every transaction fee that people like me and you send as part of the transaction get collected by the miners who actually mine the transactions. The winning miner can keep the change or the transaction fee on the block's transaction. As the amount of coins created with each block diminishes, which in some point of time will be zero, after no new coins are released, these miners will only receive the transaction fee as the reward for the work that they do as miners. Let's just look into a small diagram or an infographic showing the process of mining. And this we can see that the first step is verifying whether the transactions are valid or not. Once they are validated, these transactions are bundled into what we call a block. These blocks are then in these blocks, the headers are selected of the most recent block and are inserted into new blocks as hash. So the chain formation in a blockchain is happening here. But whether this particular block will make part of the existing blockchain or not is done after the next step, where the proof of work problem is solved. Once the solution is found, the new block is added to the local blockchain and propagated to the entire network. And the entire network agrees that this particular block is part of the existing blockchain once this entire mining process and validation of the transactions has been done. Let's just have a look at different types of minings or types of mining that are available in today's technology. We can just see that there are 4 types of minings that can be done. CPU mining, a central processing unit mining, a GPU mining, graphical processing unit mining, FPGA, field programmable gate arrays mining, or an ASIC, application specific integrated circuit mining. Just to have a look at these one at a time. In CPU mining, earlier Bitcoin and similar altcoin wallet clients allowed users to use their computer's CPUs to mine. The advent of GPU mining made CPU mining pretty much financially unwise and unviable as the hash rates of the network grew to such a degree that the amount of bitcoins produced by CPU mining became lower than the cost of the power to operate a CPU. The option was therefore removed from the newer versions of all the wallet applications that we currently see. In fact, the blockchain that we are currently using, FLO, the recent version of this particular wallet also has discontinued the mining feature from their wallet application, which is actually becoming difficult, wherein even if we want to mine testnet coins for our testing purposes, we need to use a miner. So that is something that we will be seeing in hands-on in our next couple of slides. When we come to the next topic of GPU miners are drastically faster and more efficient than CPUs. It was found in some point of time during the process of mining started that GPUs, or the graphical processing units, or the processors available in your computer graphic cards, which are generally used for watching high definition movies, playing high definition games, and doing all visual and graphical tasks. It was found that the GPUs could mine at much faster rates than CPUs, as they have drastically higher hash rates, and they could generate higher hash rates and could solve these mining problems at a very fast rate compared to CPUs. So this advent of GPU mining pretty much made CPU mining obsolete. GPU mining is something that is currently practiced as well, but it has been noticed that the GPU mining part is also becoming unviable and unwise to use due to the huge amount of electrical power that is being used by these, and also the GPUs are pretty expensive. The next type of mining that we are going to see is FPGA mining, or field programmable gate arrays mining. FPGA mining is a very efficient and fast way to mine cryptocurrencies compared to GPUs, and obviously outperforming CPU mining. FPGAs typically consume very small amount of power and provide relatively high hash rates, making them more efficient and viable than GPU mining. A similar sort of a mining possibility is ASIC, which is, I guess, is a very popular and probably the most popular choice of miners who mine professionally, or who mine coins as professionals. So ASIC mining is something which is called an application-specific integrated circuit. It's a microchip basically designed and manufactured for a very specific purpose, in this case mining of cryptocurrencies. When we see miners, the ASIC miners come in different forms. Like, it's an application-specific integrated circuit. Means these microchips are specifically designed to perform a specific task. So in case of GPU and CPU mining, you can use any type of coin mining. You can use a CPU or GPU to mine any type of coins, regardless of the algorithms that they use in their mining. But in ASIC miners, you have to purchase, or you have to acquire the ASIC miner, which can perform the algorithms which the coin that you want to mine actually follows. For example, FLO, the Bitcoin, the coin that we are going to be using, it uses a mining algorithm known as Scrypt, SCRYPT, and the ASIC miners that need to be used must be compatible with that. So you can't buy a generic ASIC miner and use it to mine any type of coins. So you need to keep that in mind. So let's just move into our next slide and look at a concept called mining pools. As I was mentioning in the differences between proof of work and proof of stake, is that proof of work is something where a lot of computational power is required. In context of cryptocurrency mining, a mining pool is the pooling of resources by different miners who share their processing power over a network to be split as a reward equally, according to the amount of work that they contribute to the probability of finding a block. It means that individually, if you put your entire computational power behind mining a cryptocurrency, you may not be successful in mining a block even for years. But if you collaborate and collectivize all the crypto mining power that you have along with different miners like you can have a pool of resources available which has a higher processing power and has more chances of solving those puzzles and having success at mining the coins that you are trying to mine. Obviously, when you are sharing your resources, the reward that is given is also shared based on the amount of work that you have put in. Mining in pools began when the difficulty for mining increased to a point where it could take centuries for slower miners to generate a block. The solution was for the miners to pool their resources and so that they could generate blocks more quickly and therefore receive a portion of the block reward on a consistent basis rather than randomly once every few years. Obviously, if you look at a miner who is working alone and getting rewarded only in a few years, it doesn't make sense. So it obviously makes sense that you join a pool and share your resources and be part of something wherein you are consistently getting at least something rather than getting nothing. The next concept that we are going to have a look at is the cryptocurrency wallets. Wallets are very important whenever we talk in terms of cryptocurrencies. Wallets are something like a software program which store the private and public keys of your addresses or your addresses in which you are collecting all your coins. So when we talked about transactions and blockchains in general in our previous session, we talked about the cryptography algorithms, the asymmetric cryptography, which uses a public-private key pair to actually encrypt and decrypt your transactions. So this particular wallet program is something which can generate these keys and it can store your private and public keys. What happens in a wallet is you generate your addresses. When you generate an address, you basically create a key pair. The wallet encrypts and stores the private key securely and displays the public key to you in form of a text as well as in form of QR codes, which you can then share to people and ask them to send you the coins to this particular address. So whichever person sends you the coins to that public key actually gets attached to the address and you can then claim those coins using the private key that your wallet actually stores. So it is very important for the wallets to manage and store your private keys very securely. If you want to use Bitcoin or similar other cryptocurrency, you will obviously need a digital cryptocurrency wallet. Let's just have a look at different wallets that are available for different cryptocurrencies. The first one that we currently here see is a desktop wallet. Our desktop wallets are downloaded and installed on a PC or a laptop. They are only accessible from the single computer in which they are downloaded. The desktop wallets offer one of the highest levels of security. However, if your computer is hacked or a virus infects your computer, there is a possibility that you may lose your funds if your private keys or your wallet is compromised. So that is something, the security of that desktop wallet is on your hands and it is up to you to ensure that your desktop where the wallet resides is kept secure. A second type of wallet that we are seeing here is an online wallet. Online wallet can also be known as web wallets, which run on cloud and are accessible from any computing devices in any location in the world. While they are very convenient to access and use, online wallets actually store your private key online onto their servers and they are controlled by third parties, which make them more vulnerable to hacking attacks. So, in case of online wallets, if the server on which your private key is kept along with other people, if the server is hacked, all the private keys of yours and other people may get hacked and the coins may get lost. So this is something which provides ease and convenience, but it is not a very good or suggested way of keeping your coins. The third type of wallet that we can see here is a mobile wallet. A mobile wallet is obviously a wallet which resides on your mobile device, and it performs pretty much in a similar way as a desktop wallet does in your desktop. But a mobile wallet can be in two forms. One, similar to a desktop wallet, where the entire wallet along with the blockchain can reside in your mobile, but it will obviously take a lot of space, but that is more secure as long as your mobile is secure. But the second type of wallet, which is more popular on mobile wallets, is similar in terms of an online wallet, wherein your mobile app actually interacts with the server application using APIs to send and receive transactions and store and receive addresses and all those things. And it is pretty much similar in terms of security as an online wallet. The next type of wallet that we can here see is a hardware wallet. Hardware wallets are pretty much the most secure forms of storing your private keys. These are similar to what you have as USB pen drives or USB devices. These differ from software wallets in that they store a user's private key on a hardware device. Although these hardware wallets make the transactions only when they are online, but the private keys can be stored on these devices offline also. And you can store these particular devices into whichever secure place you have in your house or your bank or wherever you want to store them. Hardware wallets are compatible with pretty much all web browsers and computers and can support different cryptocurrencies. It just depends on which one you decide to use. What's more is that making a transaction is easy. You simply need to plug in your device to any internet-enabled computer or device, enter a PIN, send currency, and confirm. The hardware wallet actually makes it possible to easily transact while also keeping your money offline and away from danger. So the security of this hardware wallet actually is with you. You actually physically need to secure this wallet. In case this wallet does fall into wrong hands, these wallets sometimes have biometric locks, sometimes have pin locks, numeric pin locks. So these are the ways wherein you can prevent people, unauthorized people from accessing these wallets. Last type of wallet that we are seeing here is a very interesting type of wallet. It is actually not a digital wallet. It's a paper wallet. And as you can see in the screenshot, it is actually a piece of paper that can be folded and kept in your actual wallet or anywhere you want. Paper wallets are very easy to use and provide a high level of security because nothing is kept digitally. While the term paper wallet can simply refer to a physical copy or printout of your public and private key, it basically is a printout of your public and private key that is generated. So anytime you can create a key pair and store the private key and the public key and print out in this form, and it's a paper wallet. But actually there are some websites which actually allow you to create these snazzy paper wallets if you want. I've just put in a URL for your reference. If you want, you can just create a wallet, a paper wallet of the cryptocurrency of your choice for fun. Just go and have a look. It's walletgenerator.net. I will also be having a look at that in our later times. So what we are going to see next is cryptocurrency wallets classifications. We saw different types of cryptocurrency wallets, but these cryptocurrency wallets, specifically the digital wallets, the software-based wallets, can be classified into two types. One, which is called a non-deterministic wallet, and which is called a deterministic wallet. Non-deterministic wallets basically work on the key pair, public-private key pair. They don't use or generate the addresses from some sort of a seed address or a starting address. The disadvantage of this type of wallet, which is also known as a non-HD wallet, is that if the backup of your wallet gets erased or lost, then it is pretty much impossible to get back. And you pretty much cannot retrieve your coins that you kept in your wallet if the wallet backup file is lost. In comparison, in deterministic wallets, the recovery of the wallet can be done with the help of 12 mnemonic English words, which is called a seed. So the deterministic wallets, what they do is they show you a set of 12 random words, which you can obviously change, but you need to memorize or write them down someplace for you to use them in case of a disaster where you lose your wallet and you need to recover your wallet. So these 12 mnemonic keys are used to generate a seed, and all the addresses are generated using the seed. So these 12 words, if you have, even if you lose the backup of your wallet, you can use these 12 mnemonics to get back your addresses and the coins that you had in your cryptocurrency wallet. So this is something awesome. What we are going to do in this session now is, since we have pretty much come to the end of the session in this presentation, what I promised you is I would be showing you how to actually mine coins using a CPU miner. I'm using CPU miner just because I don't have an ASIC miner, and we just need to show you the concept of how a cryptocurrency mining works. So pretty much the concept is pretty much same for any type of miner that you use. So what we will be doing is we will be using a cryptocurrency CPU miner, which is called CPU miner. So let me just stop the presentation and show you the mining process. Please give me a moment. So what we have here is, first of all, I will just like to show you the paper wallet that I was showing you. This is the walletgenerator.net site. In this site, if you go, you can just have a look at all the coins that this particular wallet supports. And if you just go down and see Fluorine coin, which is the old name for Flow, we just click on it, and this entire wallet will get converted for generating addresses for Flow. So what you just need to do is you need to type in some random characters just for security purposes. They just allow you to add some random characters, or just move your mouse to generate some characters. And once the progress bar fills in, you have a secure random seed key which is created, using which they create your paper address. So voila, we have a new address with the public address and the private key, which you can just get a printout and store it by folding like this, and you have a paper wallet. What this particular website suggests is you do not use this online version. What you can do is you can just download this entire website into your local computer and then generate the addresses and the wallets in your own computer by disconnecting the internet totally. They say this just because it can be the addresses that you generate can be hacked over the internet. So this is something, this particular GitHub link, you can just go and download this entire website and create your own paper wallets. Okay, so let's go back to mining. The miner that we are going to be using is called a CPU miner. What we will be doing is we will be attaching all the links of these sites into the YouTube video that we post, and the descriptions, in the description we will be putting all the URLs that we are using. So this is the particular link in GitHub wherein you can download the latest version of the CPU miner for the operating system that you want to use. Generally, the miner is available for Linux, Mac OS and Windows. What I've done is I've already downloaded my copy of Flow miner, CPU miner into my computer, and it is already downloaded. So I'll just show you that particular mining page. So this is something that after downloading, I have a 4.5 version. So once you download and extract it, you will see these 4 files. And the only file that is of our concern is this minerd.exe file. In some computers, what I have seen is, in some computers, the antiviruses may treat this particular file as a malware. It is because in some of the websites and some web pages that you visit, they actually use some sort of JavaScript miner application to use your computational power to mine cryptocurrencies whenever you visit those sites. So this particular file may get tagged as a virus. So, but don't worry, just add it to an exception and you can just start mining. So what we are currently going to do is we are going to see mining in two different ways. One, using a mining pool, which I'm going to be using. And the second is mining testnet coins individually, because testnet mining is still very easy and you can just run your miner for a couple of hours and you get some thousand coins mined for you in testnet and available for testing. So what we are going to see is, first, we are going to see how we are going to mine using a mining pool. So what we have here is a mining pool named flow.supernova.cc. I will be adding this URL to the description as well. This is a flow mining pool that is available and it's known as Supernova. If you want to know more flow mining pools, you can go to the Flow website, which is flow.cash, head over to the forum section, and the forum.flow.cash site should open. And in this, if you see, there is a section called mining. In this, you will have all sorts of different mining pools details available in different forum posts that we are having here. So this is something in this particular forum site. If you go, you can have all the details regarding mining and all those things. If you just go to this mining guide, there are lots of mining pools that are available, like flow.supernova, AIK pool, and all these things are available. So you can use any pool of your choice. I'm just using Fluorine Coin and Supernova. What you need to do here is you need to create an account by registering and create a worker. Once you create your account and log into this particular flow.supernova account, you will have this particular section in the left side wherein it says my workers. I'm not going to click on it because once I click, it will show all my worker usernames and passwords. So I'll just let you know that once you go to this, you need to create a worker wherein you just need to add a worker name and a worker password. And that's it. After that, what you need to do is you have your miner downloaded. What you have to do is start this miner with a set of arguments which is available here. So I'll just show you how to mine using a mining pool of Supernova. So this is the folder that I have, which is Pooler CPU Miner Win64. Under that, I have the minerd.exe. So what you need to do is you need to open your command prompt, find this particular file minerd.exe, which we downloaded over here, and what you need to do is you need to enter these command line arguments. So just let me show you which parameters are being passed. The first flag is the URL. It actually needs to pass the actual mining pool that you are going to use. So the mining pool URL that we are going to see here is flow.supernova.cc, and the port number that Supernova uses is 3210. This entire information is actually available in their website. If you see, this is the entire values that is available. So I just copy pasted those. But I also would like to show you this particular term that we are using here. It calls stratum plus TCP. TCP is a transmission control protocol that is used for transmitting all data packets over the internet. Stratum is a protocol similar to TCP, which is used only in mining. So this particular flow mining pool, Flow Supernova, uses Stratum and TCP both as a protocol for accessing it. Then what we need to do is we need to mention the algorithm that is being used to mine this particular coin. As I said, Flow is a cryptocurrency that uses script algorithm for all its mining processes. So we need to specify this. After that, we just use the user pass parameter to set our username and password for our mining pool, and we're done. But what I've done here is, for the benefit of you people, is that I've just created a batch file, and it will just run this entire command, obviously with my username and password, and start the miner and start mining. This particular miner which we are using is a CPU miner, and it is mining LiveNet Florine coin or Flow coins, and it is pushing its entire resources to the Florine coin Supernova mining pool. Let's just start it. Once we start it, this particular screen comes up, and it just starts the entire mining process. And what you can see over the screen here is my computer's 4 CPU cores are being used for this particular mining operation. And what I am contributing to the entire mining pool is 6.62 kilo hashes per second. In terms of mining terms, this is very low. The actual miners who actually do get mined or do get some rewards, they have giga hashes of hash rates available with them. In terms of that, we don't have anywhere near those computing powers, and obviously we do not expect to have any coins mined ourselves. So our only bet is, if we just use some sort of mining pools like Supernova, we can have some sort of share that we pass. So if you just see, this entire process just runs, and your CPU consumption goes to a very high level because your entire CPU is being currently used for this mining operation. So to stop this, you just need to press Ctrl C, and this process will stop. So that is something which wherein we can use the CPU miner to mine Florine coins over a mining pool on LiveNet. The second type of mining that we are going to see is mining individually without using any pool, and mine or using a mining pool also to mine testnet coins. So what I have also here listed down is an individual mining on FLO testnet. This is another testnet mining pool, which is known as testnet.oip.fun. This particular pool is generally used for the FLO community for all their testnet mining operations. OIP is Open Index Protocol, which is maintained by the FLO community itself. And the command that we are currently seeing over is pretty much same. You just need to invoke the minerd.exe command along with the URL of your mining pool. The testnet.oip.fun is the URL, and they use 3042 protocol. Obviously, the algorithm is script, and we need to, in this particular mining pool that we are seeing, they do not actually require any username and password. You just need to pass your flow address that you have, and it will just mine all the coins that you mine, and it will send back those coins to your address that you mention here. So what I have done here is, I have a particular wallet. It's a desktop wallet for the Florine Flow coin, and it is working on testnet. So the wallet currently is pointed towards the testnet blockchain, and the entire number of coins that you are seeing, 20,469, these are actually testnet coins which do not actually have any values. These can be used in creating apps and testing applications. So what I have done here is, I have created some receiving addresses, and one of those receiving addresses, I have copied the address into this particular command, and then I will be running this entire CPU miner. What you will see is, during running of this particular CPU miner on a testnet, we get much more success than what we had with the Florine coin mainnet mining pool. So let's just start on this, and it is pretty much the same, and I'll just show you the screen. And if you see here also, we are not generating a lot of hash, but even with these low hashes, you can see these screens saying yay. What this means is, whenever this says yay, it means that we have solved a problem, and we have actually cracked a block for ourselves. And what it is doing is, it is actually mining those blocks, and we are getting the rewards for those particular blocks that we are mining. So what I have done is I have actually attached one of my testnet addresses to this particular miner, and all these 4-5 successes that I get, I will be rewarded for those. And what I will be getting is I will be getting the block reward for that particular block that I mined, and also any transaction fee that is attached with it. So just for the demonstration purposes, this morning I ran the miner for a few minutes, and I actually mined a few coins, and they came to my account like this. So once you mine and your particular wallet is opened after the mining process is completed, it usually takes an hour or two for the balances to reflect back into your account. So if you see the mining process that I did this morning, sometime this 21st and 20th of August, I got some 0.51, 0.50 coins for my efforts. So this is something that is required now to gather the FLO testnet coins also. And the process and the concepts and the technique is pretty much same for mainnet as well as your testnet coins. So this is the entire process of blockchain mining or cryptocurrency mining that we can see. So today's session is pretty much over, and what we will be doing is we will just going to have a look at what lies ahead for our next session. In our next session, what we plan on discussing is about FLO, the blockchain that we are going to be using for our blockchain app development. We will be discussing some of the features and basics of FLO blockchain, its similarities and differences with Bitcoin, and one of its most important feature, FLO data. And some of the use cases of FLO will also be discussed. I hope that this was an informative session for you all. I guess we have extended the session by about 5 or 7 minutes, but I hope it was an informative session for you all. We would be happy to receive any suggestions, feedback, or questions regarding the sessions and topics in our email ID mentioned on the screen, abhijit@366spytech.com. We usually try to revert back within a day or two with your answers. We would also request you to subscribe our YouTube channel and join the Telegram group if you haven't already done so. Also, we would request you to please spread the word about SkyPiCast and the sessions so that we can reach out to more of you in future. Thank you.